Let's recap what we have learned from the first law and the second law. The first law deals with when the net force is equal to 0. The second law deals with the net force not being equal to 0. When the net force is equal to 0, the object is said to be in inertia. What does it mean? If an object is at rest, it will continue to be at rest. The initial and the final velocities will be equal to 0. If the object is in motion, it will continue to be so. That is, the speed and the direction will be same. That is, the acceleration will be 0. Right? One more way of putting across that the object is in inertia is to tell that the object is experiencing a balanced force. Or we can tell the object is in mechanical equilibrium. All of this means the same. That is, the net force is equal to 0. You need to know this language so that you can handle complicated questions, tricky questions. Okay, the next thing. When the net force is not equal to 0, what happens? There will be a change in momentum. But what is a momentum? Momentum is nothing but a product of mass and velocity. So the force that we apply, the unbalanced force that is, will result in change in momentum. And when we divide with respect to the time we apply the force, we will get back the amount of force, or we will be able to calculate the amount of force. That is, the rate of change of momentum will give us the force. And one more expression that we derived was force is equal to mass into acceleration. And so acceleration is directly proportional to force, and acceleration is inversely proportional to the mass. We'll be understanding this practically. This is about your first and the second law. You need to pause and write all of this. Don't write this part. Write till this part. Okay.